Now we want to talk about the probability of getting a head on the third of 5 flips or getting 3 tails. So you want to orient yourself to what happens when you flip a coin 5 times. You can visualize the sample space, you could visualize the tree, or you could visualize the listing. It's a little too long to list, although it would be feasible to do so, but the same reasoning we use here, we would use if we had, say, 10 flips where there are 1,024 possible outcomes. So we want to approach this in a way that doesn't rely on listing or directly representing the sample space. So you want to think through this. Okay, what's the situation when you flip 5 coins? What can happen? How many outcomes are there? How do you count outcomes in a coin flip situation? Well, okay, 5 coins with the probability of head on the third flip or 3 tails. Now, I've got this little diagram here. These are the slots that we have to fill when we flip the 5 coins. We've got to put a head or a tail in each of these, and that's going to give us an outcome. And every different way of doing that gives us a different outcome in our sample space. There are 2 possibilities for each. So there are 2 times 2 times 2 times 2 times 2. That would be 2 to the 5th, or 32 possibilities for the outcome of flipping 5 coins. Now, not all those outcomes have a head on the third flip. Not all those outcomes have 3 tails. Well, let's see. Let's start by thinking, well, probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So what we want to do is we want to figure out the probability of getting a head on the third flip, probability of getting 3 tails, and then the probability of head on the third flip and 3 tails. It's fairly easy to get the probability of a head on the third flip. It's either going to be a head or a tail. Third flip is going to either be a head or a tail, so the probability of a head is 1/2. Fairly obvious. Probability of 3 tails. What's the probability of 3 tails? Well, you want to think back to how we did this. One way of looking at it is we got to pick 3 of these positions in which to put the tail, which means we've got to pick 3 positions out of 5. So we pick 3 out of 5. How many ways are there to do it? It's 5C3. Okay, it doesn't matter in what order we pick the 3 places for the tail. We get we're picking 3 out of 5 in which the order doesn't matter. That's 5C3. Now you could reason that out in other ways. There are 5 possibilities for where you put the first tail. That leaves 4 possibilities for where you put the second, 3 for where you put the third. So there are 5 times 4 times 3 ways to put the 3 tails in here. But the order in which you put them in doesn't matter, and there are 3 ways, 3 factorial, 6 ways to rearrange to put the 3 tails in order, to pick 3 tails for 3 given positions. There are 3 possibilities for which position was picked first, 2 possibilities for which position was picked second, 1 possibility for which position was picked third. So the number would be 5 times 4 times 3 divided by 3 times 2 times 1. This is reasoning we've been over fairly extensively. It could be reasoned that way. It could be reasoned as a combination, and you could also reason it out or represent what happens on 5 coins by writing the Pascal triangle down to the 5 coin possibility, where the 1 here stands for 0 tails. That's the number of ways you get 1 tail, number of ways you get 2, number of ways you get 3, number of ways to get 4, number of ways to get 5. The number of ways to get 3 tails is 10, which is what you get if you do 5C3. And the total of these numbers, remember, is 32, or 2 to the 5th. And I mention this partly because people didn't do real well on the test with Pascal's triangle questions. You want to understand what Pascal's triangle is telling you in a number of different situations. So you definitely want to understand this. Okay, any way you look at it, the probability of getting 3 tails is 10 out of 32, which reduces down to 5 out of 16. Okay? Now, what's the probability of getting a head on the third flip and getting 3 tails? Well, we can draw 5 slots again, which we've got to fill with heads or tails. This one has to be a head because we're saying we get a head on the third flip and 3 tails. So the head has to be there on the third flip. Well, that leaves us 4 spaces to fill with 3 tails. So we got to pick 3 positions from the remaining 4. We fill 1 with a head. We got 4 positions remaining, and they've got to be, 3 of those have to be tails. How many ways are there to do that? Well, that's 4C3. We're picking 3 positions out of 4. Again, the order in which we pick the positions doesn't matter. Only the positions, where the positions are, matters. So the probability of getting a head on the third flip and 3 tails is 4C3 divided by 32. That's 4 divided by 32, which reduces to 1/8. So now the probability of getting a head on the third flip or 3 tails is what? Probability of a head on the third flip, that's 1/2. Probability of getting 3 tails is 5/16. We add those, but then we subtract the elements of the sample space, the number of elements of the sample space, or the probability of getting both the head on the third and the 3 tail, so that we don't count any of those possibilities twice. Okay, and that we're going to subtract the 1/8. So 1/2. Now we could, to do these fractions, we put them over common denominator, and naturally 16 would be the least common denominator. That's what you would usually use in just calculating this, but I've chosen to use 32 as the common denominator just because that's the number of elements in the sample space, so that these numbers are all going to be very familiar. Okay, so 1/2 is 16 out of 32. There's 16 ways to get a head. 16 out of 32 occurrences give us a head on the third flip. 10 out of 32, that's a probability of getting 3 tails. There are 10 ways out of the 32 to get 3 tails. Reasoned by Pascal's triangle, reasoned by combinations, or reasoned by just using the fundamental counting principle. Okay, and here then we got 4 out of 32, 4 ways to get a head on the third pick and tails on 3 of the remaining 4. We do that, we get 22 out of 32 reduces to 11 out of 16.